difference with our offices. Go.
Right, well that's a brief insight into the software and what it can do, but it's not just from an engineering viewpoint, it's the fact that it gives us a great deal more control, and the output is suitable to go into a technical file that's read by anybody, because it's pretty pictures, exactly. These are the loads at that point. There's no dubiety. So that's our bit of showing off. Anybody got any questions on what I can do or what?
Just one question. In terms of files, can you import from other CAD or do you have to build models?
Draw it in AutoCAD, bring it in. You can put it back out to AutoCAD. If you've got it wrong, change it, bring it back. It's that's not the simplest of operations that it might be, but it does work. Yes?
Yeah, in terms of like 50k price tags that have a range of smaller operations,
Yeah.
which you started running retro testing existing structures?
I'm sorry, can you get the mic?
Have you got, sorry.
Have you started or considered retro testing existing structures that have already been designed and built and feeding them into the system so that we get better analysis on those?
We have been asked to do that very thing by Colin, who's gone on the phone somewhere, I think. But yes, we have. We are doing that exactly, looking at what was analysed before and what answers we get now.
And when we first got the software, we were concerned about validation, weren't we?
Yes.
And the first few projects we did, we used the older software, which we've been using for many years. It's a German software package that was originally developed to help build the Munich Olympic Stadium in 1972, which is giant sales. Go ahead, Serena.
Will you be offering this service to other people that provide structures?
Of course, we're backroom boys to the trade. We work with anybody. And we're not here to sell our services, we're here to show what's available. But if anybody wants to sign on the dotted line,
I'm a consultant, which means whore.
Would that come in useful, hopefully we never have that, but in accident investigation, would you put all the detail of the structure in the hazmat?
Yes.
tell you what it should do, yeah.
You can find out what caused it.
Yeah.
We're actually very keen on the fact of, this morning we talked about dissemination of information and technical books. I'm keen on this. I'm a practical structure designer. Alan is a structural engineer. I am not a structural engineer. I work as a structural engineer, but I really design and build structures for use. I know how to reduce the component count on a structure so you use less bits. I know how to make it go back together easily, mostly. And a lot of prototypes are one-offs, and this is what you have to remember. And a lot of firms who build their own stages, every one of their stages is a prototype. So keeping the components common is important. Optimization of components so that you get the very best and the most you can from that piece of equipment is only good for business. And this helps you do all of that. Plus, the game graphics, the computer game graphics output help everybody else understand what that structure is going to do, which is what we were talking about this morning. That's why I like it. Where are we, Alan?
I think that's ready to go to our next presentation. What time is it?
You've got time for a few more questions and answers if you want before the next session. We're only 10 minutes away.
Okay.
Can I just ask about the load cases? You're setting those, I presume that's, for instance, like I see in the corner, it says you win 0.5 direction 1. So
Let's show it.
you set up whatever load cases you want for finding the worst case scenario
Yeah.
in whatever direction.
It's not tricky, you've got an arrow. That's the way the wind's going. And you set the load, outside load, inside load. For engineers, you've got your internal pressure, your external pressure.
0.5 to 0.8.
And then you can apply uniform loads. In that latitude tent, I was very concerned against somebody leaning on the A-frame, which is balanced, holding the whole thing up. So I put a 2.5 ton load at the top of one of these A-frames to see what would happen. Nothing happened, surprising, but the load went, you can see the analysis.
You see the wind loading changing.
It solves each load case. If you're running 15, 20 load cases, you can go and make a cup of tea and come back and you're going to get your answers.
And we can put as many load cases in here as you like, and each time we can put like a what if, let's double the load and just see what it does. And it's so easy to do it. In the old days, it used to be a morning or a day just to do another load case. This is instant. This is real tools. Go on, Tim.
If we all club together, could you give us a set of generic load cases for Harris fencing, you know, steel shield, polyjohns, zip-up tower that promoters decide to put banners down the side of or whatever? You know, that would just be such a fabulous repository of actual real-world data that we could then say, no, mate, don't.
Alan is so goddamn clever, he can do that on the back of a fag packet for you.
I'll buy you a drink, Alan, if you give me the files. You know what I mean?
I can tell you.
There's something I want out of this, you know, these 2 days. It's that kind of stuff so that we can say, look, you need half a ton at the bottom of the zip-up tower.
Yeah, yeah.
You want an 8x8 toilet sign on it.
Exactly.
It's only 50 grand.
But
No. I'll tell you what, we'll do that one as a gift for you. We'll do that one as a gift for you.
Harris fencing is what we call the autumn leave of fencing in Scotland. Because the first time the wind blows, it's scattered all over the landscape. But yeah, yes.
Can you, if you've got a structure that's maybe to some extent reliant on ground anchors or guides, can you recreate soil conditions?
You can put springs in to represent non-static restraints. Haven't done that yet, but I will do springs. Yeah, yes is the answer. Haven't done that yet. We'd have to take advice from the designer about that, but it is a completely non-linear package. So a spring, which you get movement in the support to get as you apply the load. That's a non-linear structure. So yes is the answer to that.
We are so committed to this package that we think, we're not sure, but we think the other people, well, we've been told, haven't we, the other people using this are using the American wind codes, which are very similar to our own, by the way. We're not trying to make a big deal of that. But we were so concerned to get accurate figures. If you look, the little patches on there, each one of them is calculated separately from building code. It's not guesswork. It's not our information. It's taken out of a book that says you will apply the pressures like this for that slope, that angle of attack. And rather than just take their word for it, Alan rewrote the code, which is why it says on here, Alan's wind code, if you look in there. And then there's an Alan's upward one, but all of it is taken from published data. So none of it is us, or our opinion, or our judgment. This is fact taken from building regulations.
It's from the National Annex to the Eurocode. It gives you all the factors are all there. Very hard to find, but they're there. And it's extracted and summated, and we did it on simple tests to prove, we get what you expect, and you do.
So when you get somebody on television saying it was an act of God and we didn't know what would happen to this particular structure, it's not true anymore. That might have been true 5 years ago or 10 years ago. I promise you there isn't much that we can't simulate with this.
Surely that's all down to how the thing is put up. It's nice when it's in a computer model, in a field, it's a different thing.
No, we can tell you what the performance will be under any given wind load. We don't determine what wind load's being applied on it, but we can simulate.
I'm not just talking about wind loads, I'm talking about failure.
Yeah. Can I follow that up with Herbie? I was just going to say, can you consider for us when the promoter wants to squeeze in another sausage concession and move the anchor point a couple of metres to the side? Take your latitude tanker.
Yeah.
Yeah. So.
Yeah. Take 5 minutes.
Yeah. That's work.
If somebody, in fact, I've got it on my laptop.
Yeah.
If I was on the site, they said, I want to move that over there. Well, I just grab it on the thing and say, how much do you want to move it? 2 metres, move it, analyse it, run it. Okay, that load's gone from 25 to 40.
So is there an app for that?
And a good idea, though.
It is. Not only am I I'm a mobile app.
Look, we haven't got all the answers again, but this is leading edge stuff. And it's only fair that a gathering like this is shown what's at the top of the market. We are going to talk about what's at the bottom of the market, which is, not being rude, market stalls, right, in high streets.
Can it simulate an abrupt change of wind direction?
Yeah.
But obviously the stresses go from one direction to another, which could be worse than just a constant direction of stress.
Not sure about that one.
No, well,
No.
It happens a lot in Wales.
yeah, well, the problem with that's going to be a fatigue rather than a...
Yeah, and we can simulate both directions, so we can then get a result from both of those analysis runs. But that's nothing that people couldn't do before. We're not trying to say that we're doing things that other people can't do. What we're saying is we've got a little bit of a sharper pencil here. And the pencil is very sharp indeed, but it's still just a pencil. It's a tool to show us how these structures should perform if we build them the way that the parameters are put into this.
The designer, Martin, was talking to me about fluid dynamics, designing the air pressure as fluid dynamics.
Which this isn't.
Which would be exactly that situation where the wind pressure varies and flows.
Yeah.
He was looking at a method of doing that, though he hasn't done it yet. But whether that just makes it beyond complex, I don't know.
Well, they are doing it on the desktop at major teams like Formula One teams. At major offices like Formula One teams in aerospace. It's called Computational Fluid Dynamics, CFD, and it's a virtual wind tunnel. And you can say the wind's doing this, and you can see the frame moving. This is not that. Each of these load cases simulates a particular... That, as Alan says, that will probably be the next stage, and he is working on it. But at the moment, this is still way better than what we had before.
Yeah.
I was just wondering if you could put like dynamic loads on the inside of the structure, if you had someone swinging or something underneath.
We can put point loads anywhere we want on any of the nodes of this structure.
If you had something like cloud swings, maybe dynamic load on that is quite strong comparative to the way that the person is
We can do better than that. We can change the gravity on particular bits of the structure.
Here we go. Ah, that's interesting. They're not supposed to be fixed. All right.
But you can change the gravity, which is kind of the same as dynamic analysis. You can change the gravity.
Consideration of dynamic movement. The problem with dynamic movement is it's that vibrational movement that keeps going backwards and forwards all the time, and that actually weakens some of the connection points, particularly when that goes on. And that
Don't know the answer to that.
Actual structures are, these things are flown into structures often.
It does do the dynamics of the applied wind loads. It's all a dynamic analysis. It's a non-linear dynamic analysis. But in applying dynamic loads, I'm not possibly it does. I haven't used it. Haven't seen that. We've just applied point loads, but there is all these factors that go with it. As I said, you can apply and change its gravity.
Yeah.
Yeah.
Well, there's a lot of talk going around, isn't there, about an article in one of the magazines this month about the ageing of aluminium trusses. Didn't we comment on that one?
Yeah.
Right, it was various people. Nothing wrong with aluminium. I prefer to design in steel. It deflects less. It's cheap. It's easily repaired in the field. It tends to be better in use and abuse. I didn't say it was, I said it tends to be. And
I like aluminium because hardly anybody else does it.
yeah,
it's more work for me. Yes.
Yeah. So, but there have been lots of questions asked about aluminium, stress fractures, aging, metal hardening with flexing and twisting over the years, and all of that happens particularly with the old-fashioned 10-year-old alloys that we're using, duralumin, with lots of copper in it and things. Modern alloys are slightly better in that respect, as we know, but there's nothing wrong with aluminium at all. Just some people prefer steel. And I'm a bigger the blob, the stronger the job man when it comes to supporting steel work. I like to see nice, hefty supports. Go ahead, Tim.
Following on from Jake's question, would this be able to give us an answer to the age-old question of is it better to restrain the bottom of a large video screen or let it flap? Some theories that it's better to let it flap so it sheds some of the energy, imposed by the wind, but then you get the harmonic motion, so it's better to tether it.
It will happily, it'll move into the wind if you let it hang and show you what effects it has. I did a test on that, and I'm very strongly in the Tesla at the bottom of it category, because if you get eccentric loading. If the thing moves out, the centre of gravity has moved out, you've got eccentric loading on something you didn't have before. So I'm strictly holding it down, fella. But there you go. But this will do it. You'll analyse. You can hang a thing and put wind on it, and it will sway out. You saw the tent blow out when we took the guy rope away. Well, the same thing would happen with a video screen if you put it under the wind load.
But will it be able to identify harmonic motion, forces set up within the structure, or are you looking at
No.
Don't think so. It does do stress ranging. It will do stress ranging if you give all the different load cases. It will be different positions. It will give you the stress ranging, which you can use for fatigue analysis. I don't think it does harmonics. I'll ask him if it does, but I don't think so. It'd be a good thing to do because he likes the challenge. Well,
one way of looking at this is that it's a very responsible way to go to get sort of fairly realistic analysis of what structure was doing at a certain region. And then he was saying, look, the business we're in is very organic. Yes, the best plans, you've got plenty of time to plan for all different eventualities. But you've got the headline map turns out one stage with another half a ton of equipment they were going to fly with. They haven't told you that, so go in there. The way that this particular software could work best for this industry is going to be quick, it's going to be cheap. So you can almost instantly do a risk assessment with some concrete evidence that this is what's going to happen.
It'll be quick. Didn't say cheap.
Yeah.
But yes, it is. It can do it on the spot, instantly.
But it does have to be affordable for people to utilise.
Yes.
Yeah.
Well, we're spreading the cost over different structures is how we have
And-
funded it.
And we're showing you how quick it is to use this compared to older output methods. And we think that although it was a big investment, we'll get our money back quicker because we've reduced time on the job. The customer's probably going to get a better, cheaper job. And that's advancement in any industry. It's not just confined to this one.
You need beyond the on-site calculations, how is it accessible to prepaid license users over the internet? I'm in a field with a dongle, GPS, so like a mobile phone network. Actually go in, you've already got data about my stage in there. I go in and say, I'm going to do this quick, and give me a figure, and I subscribe to how that service.
I think you're better off having several load cases in the first place that simulate what you're likely to
But
get.
yeah,
But we could, yeah.
the fact, the instant nature of this means that we can do change loading, change analysis in minutes, which things would have taken a week before to get it all organised through the different systems, but we can do it in minutes.
How long does it take to put all the data of all the components?
Yonks.
Is that like 6 months, a year's worth?
No, that particular one is a major, as you've just seen in the slide, it's a major structure.
We did the
A
Megadome.
month, I think.
Megadome in a couple of weeks.
Yeah, something like 2-3 weeks.
That's huge.
And then manufacturing information. This whole package here also does the patterning and divides the roof up for manufacture. It shows you what all the angles are of the cables to help you with manufacture, the 3-dimensional angles, not the 2D angles. It's difficult. If you're experienced, it makes you better. If you're not experienced, it helps you more. It's a very, very benign thing. And you know what they say, experience is the hardest kind of teacher. It gives you the test first and the lesson afterwards. Software's a tool, once again, it's another tool in your toolbox. It just happens to be a very good tool.
That's almost a kind of danger. The more this turns into an app, and everybody can do it, it's the growing problem is going to be, are we asking the right questions and are we servicing?
You'll never get this to an app.
But too many, if you go in that way where it becomes that easy for people to get that information and maybe aren't experienced or qualified
garbage in, garbage out is the big problem.
Yeah.
You have to have a clue what you're doing.
I'm going to wind this one up, Alan, if we can. Yeah, we're just about done. What we've learned in this one, and I hope you've learned, and I hope we've explained it clearly and concisely, is that there are new tools available. Not just from us, from other people too. But more important, you've played with a bit of cloth, you've seen the shapes, you've seen how a floppy bit of paper can support loads. So we've come to 3 conclusions here. That thin materials can perform really well if they're used in the correct configuration, i.e. use the shape to control any loads. That slender thin-wall members can be used if inspected and maintained correctly. We were talking about that before with the trusses and the aluminium. Nothing wrong with thin-wall tubes, but you must inspect and maintain them because thin-wall tubes are more susceptible to folding. And that tension fabric is a good structural material if edge stiffening and point load details are adequate. Now, what we haven't covered, and which we're doing some work on, is inflatable double skins for stages. And you use the air pressure inside the skin to stabilise the frame. And that is used in other areas, which we won't bother with here today, but this is once again a tool that will allow us to do that. We can do inflatables with this, we can do air balloons, we can do geodesic domes. It's not just related to tents or stages. You could design a skyscraper with this if you wanted to. You wouldn't use it though, you'd use a tool that's designed for that really. This is a general software that encompasses everything to do with temporary structures, with the fabric, the aluminium, the steel. It doesn't care what the materials are as long as you put the properties in properly. So it is a tool, it's a very wonderful tool, we love it. And the main thing that you need to know further down the line this afternoon and tomorrow is that this is a tool, and other people have tools that will allow you to understand the structures better. A technical book that will have more information in, better information and clearer information so that the non-initiated can look at it and figure something out. And somebody said, well, tell us what you think we ought to be doing. I'll tell you, we think we ought to have better documentation for temporary structures. And that helps everybody. Yeah? Are we going to do the 5-minute thing or move straight on? No vast movement. Right, we'll move on to our first guest speaker, Simon James from the Event Safety Shop. Thank you very much, Simon, for agreeing to do this. I'll just close this down, give you a clean shot of it.
Hi, good afternoon everybody. I've been asked by Rudi and Alan to come up and have a talk, and I was a little confused about what I was going to say. I think to start with, I've put together a short PowerPoint which I will talk you through, but actually looking around the room I see that gathered here today we have a vast wealth of experience, some really good people in our industry, and I think rather than me pretending I can teach you all everything, I think it would be a great idea once I've finished if we go through and talk through some of the issues that maybe I'll raise and think about how your own experiences and how we can all bring them together to try and make it safe. Because back to the question that I heard earlier about whether we're confused about whether we want more or not. I think everybody in this room, my aim and everyone else's aim is to ensure that it's safe out there for everybody. Whether you are a member of the public going to see a show, or whether you're an employee who's having to build it. And I think I'd like to think that everybody in this room starts from that premise. I don't think anybody, I certainly don't think we need any more legislation. I think there's plenty out there. But on the other hand, how we use that and how it's enforced is the important part. So, I've entitled my little talk, Structures from a Safety Officer's Perspective, because that's what I am. So, for any of you who don't know who I am, my name is Simon James. I try to put a very brief thing here. I studied civil engineering at Polytechnic, I like to say Polytechnic because it's now called itself, very smartly calls itself a university, but when I was there it was a poly. It helped me understand structures and things, although I say it was civil engineering I did, not structural engineering, and I'm certainly not by any stretch claiming to be a structural engineer. However, I do have a fundamental understanding of what structures are and how they stand up. However, something got in the way in that these tours kept coming through the town where I was, and I saw all these people appearing to have great fun travelling around the world and going off and doing things, so I jumped on the tour bus and ended up becoming a lampy, and 12 years later suddenly went, my God, what happened to me? As part of that, I ended up building stages. So it's people back there who know me from, I sat with Jumbo and we built stages many years ago. Around the world, which was great fun, and again taught me a lot about structures, how to do things safely, and how not to do things safely. I turned into a rigger and spent a lot of time rigging around the country and around the world, and then somehow I ran into this gentleman called Mr. Roberts some time ago, who's told me about this company that he was working for, who were doing safety, and I thought, oh, maybe that will keep me at home a bit more. I need to think about what I'm going to do. And so ended up becoming a safety officer, doing some qualifications. I'm now proud to be a director of the event safety shop, along with Tim and Mike, my other colleagues who are around the back. And as part of what I do for TESS, is say I am a safety officer, which is why this is my perspective on structures. And as a little add-on, I just put at the bottom there that, I say, as I burst in and spoke earlier, I sit on the AGOTS committee of the Institute of Structural Engineers. I sit there as a representative of the PSA, so hopefully I'm trying to represent most of the people around this room. It's about we are the voice of the industry, or I try and be the voice of industry when we come up against some of the more obscure bits and pieces that we try and get legislated against or whatever. So the AGOTS committee, for any of you, it actually stands for Advisory Group on Temporary Structures. So they are the group that puts together TDS. Funnily enough, we're meeting again for our 6 monthly meeting next week. So we'll see what comes out of that one. So why am I here? Why am I standing up here? Well, I put this down as to try and get a perspective on common issues arising from a multitude of structure types. Okay, I know that Rudi and Alan have talked a lot about tents. I see massive amounts of different structures on all the sites I go to. Temporary structures range across a huge type and range. And I've got a few photos coming up which say are in no way supposed to be, anything good or bad. They're just some of the types of different things that we run into. So there we have a temporary structure built in. For any of you who know the building, you can see the roof. It's one of my favourite roofs in the world. Is St Pancras Station, and we were involved in the opening ceremony there. And this was a structure that was put in by Shirley's, and that was basically just put there so they could then sit a seating rake on top of it. As you can see, a very complex, complicated structure that had to go in. Lots of documentation over how we could get it in, and certainly from a perspective of working in that environment between the railways and a construction company, was possibly one of the most highly regulated environments that I've ever had the, I'd say, misfortune to work in. There was a few characters on that site from the operation who were fairly difficult, who weren't used to the way that we worked, and we were not used to the way they worked. So I can't remember what year this was now. I think it was 2007, wasn't it? 2007, I look back at my memory back there. So again, this was, we ran into awful lot of culture exchanges, shall I say, between the construction industry and ourselves about how we did it. But we all got along, we all did it properly, and it was a safe and well-managed event. Something completely different. Here we've got saddle span, sat in the middle of a field, obviously no punters, no nothing at the moment, just a straight saddle span. Again, I didn't pick this one for any other reason apart from I found the photograph. It was the first one I came across. Another type of structure that we are expected to look at, pass judgment on, and how we're going to manage it. A tent, a big top. Yeah? What could possibly go wrong? Well, we all know what can go wrong with them. But again, another type of structure. I've seen all the pretty diagrams now that maybe we can get put in, and say when I get my app on my iPhone, I'll be able to tell if I can hang 15 circus performers hanging off the top of there, swinging backwards and forwards, I hope. It might take a few years, but they'll get there in the end, and it will be there. At the moment, I just have to, what I have to do to make sure I can do that is go back to designers, ask for information, try and find out whether this structure really can do what I need it, or not what I need it, what my client needs it to do safely. Small marquees, don't forget them, as we've said. We've all talked about the fact that you know, these big structures, they have big engineering behind them. They have lots of people. We have lots of design calcs. But when we just get small structures like this, are they the forgotten ones? But when they fall over, if they fall over, they can cause just as much damage. They're going to have people inside them. They're going to hurt people. So don't forget the small stuff. So why do we need to do structural sign-offs? One of the things I'm asked to do as part of our job and part of the work we do for our clients is we say we will sign off a structure. Or the client comes to me and says, oh, you can sign off that structure. I put that back to them saying, I won't sign the structure off, but I will work with the people who will sign it off, because I am not the competent engineer or the person who has built that structure. But why do we need it? Primarily, we're using sign-offs to ensure that it's being built correctly. Yeah? The people who are actually building it needs to ensure that they have, and it acts as a memoir to them sometimes. The amounts of times we've sat there with people in the past with some very big companies and said, we will be expecting your crew chief to sign off the structure, and they go, oh no, he's not doing that. We go, what do you mean he's not going to sign it off? Well, he's not there to do that. You go, what, so you're ready to put this person in the position where he's going to build this multi-million-pound structure above our heads, but he's not willing to sign a piece of paper to say that it's safe. Well, it's not coming on our site then. Yeah? We're not asking that person to say it's correct, we are asking that person to say it has been built correctly. It has been built according to the plans that that competent person has been given. It's there to help cover the client. I know we keep talking about this, but we need to ensure that our clients and everybody down the chain is actually covered. Yeah, to make sure that they have done the checks and balances, to make sure that if something does go wrong, it can be taken back to find out where the mistakes were, what happened, why did it go wrong, who wasn't looking after it. So that's accountability for all parties involved. Okay, that means whether it's the client, whether it's the contractor who's built it, whether it's the engineer who's designed it. All these lines of people all have to be held accountable, and that structural sign-off, that sign-off can be part of that process. Okay? So what documentation should we be looking for? Well, obviously that's a lot of what we've been talking about this morning. And I would say the first thing that I'm looking for, if I'm the safety officer on a site, the first thing we would have been asking for is structural drawings. Obviously now, maybe what we should be asking for is full 3D rendering and lots of pretty load case dynamics to show us where things are and what things are doing. But predominantly, you cannot ensure that something is safe if you can't see that it's actually being drawn properly, which means somebody has taken the time, a designer has done it properly and has drawn those drawings and been able to prove to himself, to start with, that that is a safe structure. Engineering calculations. Alan has shown us lots and shown us how hopefully it happens now. As he said, it used to be a pile of paper that big. Now hopefully it's going to be an output in some pretty pictures. I'm not for a minute thinking that that's the end of it, because there's an awful lot of very clever maths behind that £50,000 programme, I'm quite sure. But ultimately you have to be able to prove these things. Now, again, if I ask for engineering calculations from a supplier, sorry, I'm trying to stop this thing flicking about. If I'm asking for an engineering calculations, I will not go through all those calculations. I do not have the understanding, and I don't know whether they've used the right formula, whether they've used the right wind code. I have to rely on the supplier has gone and asked the right questions of his engineer to make sure that he is getting the correct information to come back to us with. Because ultimately, the supplier of that structure onto the site, which is going to be a supply company, a contractor, has to be able to prove that it's safe. And I would have liked to have think that if they brought something off the shelf and they've been supplied with the calculations, they will then go back and get those calculations checked by their own engineers. Yeah, it may not be their in-house engineers, they may be using consultant engineers who will do it. And I certainly know that the calculations... Sorry, stop this. Am I a bit loud?
Just pull the boom away from you at your mouth a bit.
Sorry. Sorry. I have a loud voice, I probably don't need this anyway. I'm laughing at the back there. Thank you.
And turn the volume down.
Do you know what?
Can you all hear me?
Yeah. Can anybody not hear me at the back? Forget it, I'll talk. I'm never being shy to talk, sorry. Okay, so our engineering calculations. Again, I'm not expecting a safety officer to have the understanding and the skill to go through every single calculation, but they need to know a few parts of it that are the critical parts. And I think when I was listening to Tim earlier, and it's something that we talked about in the car on the way up, from my perspective, and again this isn't a criticism of engineers, but it's one of the things that you need most as a safety officer is almost a fool's guide to those engineering calculations. What do I need to know as a safety officer? What does the client need to know? Two things really. When's it going to blow down? Blow over, if it's an outside job, okay? So it's failure, wind speed, and what we're supposed to do about tying it to the ground, holding it down, what that's going to require. Okay, all how you get to the rest of that doesn't actually deeply concern me. But I do need to know that if I need 1 tonne on that corner or 25 tonnes on that corner, that's critical. And even if I do have 25 tonnes, if that stage is going to blow down at 25 metres per second, I need that piece of information. I don't care where the wind comes from. If it's going to blow down in those wind speeds, I need to know, because then we get a managed wind plan that means we can make sure that we have cleared the site if we are getting anywhere near those wind speeds. Okay, so as we've heard earlier, we saw the shots. I certainly haven't put any pictures of disasters in mind. I knew there would be others. We've all seen those pictures. They horrify me when I see that thing going down in slow motion. And what horrifies me even more is, as you say, when you read the information and you realise they knew it was coming. An event down the road stopped, they didn't. Yeah, that to me just horrifies me. And it will obviously, people will pay for that, but more importantly, people have paid with their lives for that. So the engineering calculations that you require, I know that from a designer's perspective, they have to go through all the different load cases, look at it from everything. But we need a simplified version that is anybody can understand, which says it needs to be held down with this amount of weight and at this wind speed it will fall over. And can I have a show of hands around? Does everybody agree that that's the kind of information that we all need? Is that, yeah? So, as I say, I'm not having a go at engineers. Engineers are asked to do stuff. I think it's the information that comes back to us through the client. And that's obviously what this book, the book that we've been talking about, the 10th book, will have those kind of bits in it, and I think that is absolutely critical. Most importantly, you need to have requested these a long time before getting to site. You don't want to be asking for these when you're wandering around in the mud and the rain. Yeah? These drawings, these engineerings, and if they haven't got them, then you should be starting to worry about your contractor. You know, if you phone up your contractor and say, we need the calculations, we need the drawings for your, so it can be checked by, possibly by our engineers, then fine, send them through to us. Now, I know, as we've all looked, we all work in the real world, things change, things move along, and it may be that suddenly the main artist has decided he's going to hang an 8-ton video screen on the back of your stage, when actually before he was just going to hang a fast fold. Yeah? So these things might need to be changed, but you need to know where you start from. And this kind of information needs to be getting to you as soon as you're, as soon as you're able, as soon as you're actually, contracting a stage. These kind of information will be sat in your contractor's, should be sat in your contractor's outbox, ready to go. So, okay, this is all very well for all the kind of information and all kind of stages that we all see all the time. And that kind of information gets used time and time again. What do you do when you run into this? Okay? It's a temporary structure. Yeah? We want to put people into it. So what do? I look and go, that's beautiful, it's lovely. But can I put 5 people upstairs? Can I put 50 people upstairs? Can I put 500 people upstairs? I don't know. I'm not an engineer and I don't know wood. So what do? How do you cope with the miscellaneous? You have to have an agreed procedure. You have to know what you're going to do with this kind of thing beforehand. These kind of structures don't suddenly just appear on the site. You know they're going to come. They're going to be part of your planning process. So you should be thinking about what you do. And as I say, that particular picture, you will probably all guess, comes from a field down in Somerset. And there is a very good agreed procedure at Somerset, in Glastonbury, where what happens if we get these weird and wonderful things, which will happen every year, every time there's better, what you do, you get a competent person. That particular competent person who looks at those structures is sat at the back of the room. Yeah? We get a competent engineer who is used to looking at different things and can give us a competent decision on whether that structure is safe. But again, as a safety officer, I can't do that. I can look at it and say, yeah, I think it's okay, but that's not good enough, we all know. So we need somebody who's got letters after their name, skill, confidence, and competence to be able to tell us that those structures are safe for us to then open to the public, so that they're not going to collapse, so that we're not going to find ourselves in the headlines saying, structure collapses at Glastonbury. So it is all possible, but it requires planning, it requires forethought, and it ensures that things on the ground can be checked. Because if you haven't got an engineer, and you haven't thought about that kind of thing, to just find an engineer like that, the drop of the hat, because you've suddenly let someone build something like that on your event site, you're going to be in trouble, because you're not going to be able to find an engineer at the drop of a hat. Certainly not one who is competent. And as I say, I keep saying I'm not trying to get engineers at all, but competency is very important in this, and part of being competent is knowing your subject matter. And there are, I don't know how many engineers there are in the UK, structural engineers, but certainly probably 95 to 99% of them aren't competent necessarily, and would say that themselves to look at structures like that and determine whether it's safe, because they don't do that. They build high-rise buildings. They build whatever it is they do, and although the fundamentals of engineering are the same, how you apply that information is vitally important. So make sure, if you're going to use a competent person, that that person is happy to take on structures that may not fit any kind of rule book that they've had before. What are you going to do then? We're going to get competent, you're going to try and get into sign-off sheets. So sign-off sheets are about, again, accountability almost, making sure that somebody is willing to put their name down to say, I have built this to the drawings. Okay, so again, possibly this won't be often miscellaneous, this is used all the way back through our standard structures. So the saddle span we saw, the small marquees we saw, all of those you would expect to be signed off by probably the crew chief who built them. It could be somebody else. That can be up to you or up to the company who's supplying it. Another thing that I've thrown in here from paperwork is inspection sheets, to make sure that you know how something is behaving, to make sure you've got the critical parts almost of a structure that you can go through and tick off to make sure that they've been done. Is the ballast there? Are the stakes there? Are all the nuts and bolts in there? Is the key structure of. Okay, there are, as you say, on every stage, on every structure, there are critical parts that must be there and must be done correctly. Otherwise, you're not going to get the, it's not going to be safe to operate in. And here, not that I'm saying ours are any special, but here's just a couple of examples that we use within our company. So we have a structural sign-off sheet, you know, venue name, name of the person signing off, company, what their position is, and then a very basic statement that comes out of TDS, which basically says, we built this to the plans and we're happy that it's going to stand up. Again, I don't think that's too onerous to ask somebody for. It's not saying, I will manage that structure. It's not saying I've designed that structure. It's saying I have built it to the correct plans as I was given. Now, if he hasn't been given any plans and he doesn't know how to build his stage, he shouldn't be signing this off, and more importantly, he shouldn't be building the stage or structure, whatever it is. Obviously, going back to our wooden house that I showed you, our two-tier bar, that's a little more tricky. But there will have been, somebody will have come up with some plans at some point, because they'll have had to cut the wood, they'll have had to design it, work it out. There should be drawings and drawings for that structure, and you are asking them to sign off against that structure. On this side, so what I was talking about, big top inspection sheet, so you know, what are we looking at? King poles are pinned, king poles are aligned, loader certs for the winches, main guide tensions, main guide pinning. All kind of things that are absolutely critical if you're building a big top. Yeah? I don't build big tops, but I get an awful lot of big tops on the sites that I'm working on, and that acts as an aid memoir for me. When I'm walking around with the person who's going to actually sign it off from the tent manufacturer, the tent supplier, I can go through all of those and go, has it been done? Yeah? It will help you, and it all goes back to ensuring ultimately that you've got a proper process in place to show that you've built something properly, or it's been built properly, and that you are all going to be safe in it. Yeah, okay, on here, there is nothing, I will say, anything about wind management plans. This is about signing structures off. What this hasn't gone into in any way whatsoever is, back to our simple things of what I want from an engineer, is, you know, the wind speed, okay? So this is a separate process. There needs to be a wind management plan, which I'll try and talk about in a little bit. So who should be involved in the signing off? Say yourself, maybe me as a safety officer, it could be on a smaller event, production managers, the event organiser, site manager. Whoever's going to be from the people who have actually ordered that tent. The client in CDM terms. And then the competent person from the structures company, it could be, as I said before, could be a crew chief, could be a company engineer, could be an owner-operator. As long as they are competent to sign it off, we don't mind. But they have to be a representative of the supplier company. Yeah? Because they are the people who, as we've shown, are going to say to you, yep, I'm happy to put my name on there, go ahead, use it. Okay? And again, as part of those, you walk around, and when you're walking around with that crew chief, and actually you've got your little list, and you're thinking to yourself, okay, and you come across there's half a dozen missing bolts on it that you can see, you go, what about those? And they amazingly go, oh yeah, 1 minute, I'll be back in a minute. And they rush up to their bolt box, find another few bolts, and try and bang them in. And it's amazing how it sharpens people's minds when you are walking around with being a clipboard pilot, which I like to think of myself sometimes, with your checklist, and you're going through and they go, oh yeah, okay, this person does know what they're doing, and so I need to make sure that it has been built properly. So, what should you be looking for when you're looking at structures? And I've put a list up here that is not exhaustive at all, but is a start of the kinds of things that I go around and look for. So number one is balance. This isn't in any particular order actually. How the structure looks. And I know Rudi mentioned earlier, you can have a beautiful looking tent. It might blow down in the wind, but if it's a really scraggy looking tent and half the wires are missing, you're probably actually going to look at it and think that's far more likely to blow down in a wind. If it looks like it's been put together properly, I'm not saying the be-all and end-all, but the chances are the people who put it together have taken care and they are thinking about it, and that is going to ensure that you've got a good structure. Bracing. Now, there's an interesting one. Certainly, you know, when you get into scaff stages, what bracing should be there, what shouldn't be there? Well, again, ask for the drawing. The drawing should be able to show you what diagonals there should be through the base of your stage to ensure that you've got a safe stage. There should be, in any marquee, there should be wind bracing in most clear spans every fifth bay. That's not, that you know, that can be different, but you need to make sure that you know what that should be. But it's easy enough to see bracing. And when you see a whole line of bracing and then there's two missing in the middle, you think to yourself, why is there two missing in the middle? You know, why is it goes all the way through and suddenly it stops and then it starts again? Should that be right? Most people, and again, you can pick up information like that. You don't have to be an engineer to see that. You can pick it up yourself, yeah? A good pair of eyes is a very useful tool. Straight and level. When you get on your stage and it's up and down, up and down, up and down, you must start thinking, well, actually, we'd asked for a flat and level stage here, so what's gone wrong? You know, you haven't accounted for the ground conditions underneath. You've got moving, you know, bouncing pieces of decking. That means there's something wrong. Yeah, the person who designed it, the designer, will not have designed a stage which has got a bouncy springy bit in the middle, unless you specifically ask them for a bouncy springy bit in the middle. So I've yet to meet a stage that's supposed to have one. No holes. Yeah, they're not meant to be holes in stages. Good thing to find, unless of course, again, you've chopped it out in the middle because you're going to put in a hydraulic platform or whatever you're going to put. Missing bolts. Often see, you know, why is it I can look up there and I can see that there's 4 bolt holes, but there's only 3 bolts through there. Okay, again, you don't have to be an engineer to notice those kind of things. Missing pieces. The lug stuck out the end. Surely there should be a bracing there. There's 2 lugs on it. Why isn't there any bracing? Ah, well, that one got broken on the way. Okay, alarm bells start ringing. Wait a minute, you haven't completed this structure. What are you going to do about that? You're about to sign it off, and yet you're telling me there was a piece that was run over by a forklift and isn't there anymore. Is that structure still safe for me? Ask the questions, find out, don't be fobbed off with an answer, yeah, it will be all right, mate. And back to my, you know, bracing, regular bracing patterns. You know, bracing is about making triangles. It's not supposed to be very complicated. You know, there are certain places where it will be. But when you're looking at a piece of truss and the bracing goes up and then suddenly it stops and it starts a different direction, ask the question, shouldn't that be turned around? Shouldn't those 2 bits of trusses be actually lined up so the bracing follows? If they can show you the tables to say it doesn't matter, it doesn't need to be lined up, then all very well. And you can be satisfied that that's the way. But most truss that I know, you want to line up the diagonals. The bracing should line up in a long line. If it doesn't, they've just tipped it up the wrong way. So those are the kind of things you should be looking for. I've gone into a bit more detail, not in lots of them, but specifically I wanted to look at ground anchors and ballast, and I know that there's going to be a whole session tomorrow. I can't be here tomorrow, and it's a session I would like to have been here, but I fear I have to be somewhere else. So I put together a bunch of pictures that I picked out of our test photo libraries that show a multitude of different ways of doing ballasting and holding it down. And just wanted other people to see them, comment on them, and again, I'm not saying they're right or wrong. Some of them I will show you have definite problems in them, but the kinds of things that go wrong. So we go through these. Okay, I was looking, the one thing I couldn't find, and I'd say that actually in tests I couldn't find any of us who were actually, I'll say this, not meant to be impolite, was that sad to actually sit there and take specific photographs of ground anchors. We've got lots of ballast.
You looked at the wrong folder, right?
So I had to take this photo and try and blow it up. But this is a classic example of, you know, it's a big top and it's got 3 stakes in it because it's holding up the king bolts. Yeah? That one looks nice, driven into the ground, looks good. You know, it's an old-fashioned style with the rope around it, but it's got a separate chain on it as well. And that, to me, in my view, as long as one condition is covered, and I'll throw that out to the floor, how can I tell that that's okay? What's the thing that's actually most critical to that? Come on.
Yeah.
Sorry? The ground itself, exactly. We're putting that in nice, well, let me get this right, nice thick clay. It's probably quite happy because thick clay tends to be gungy and holds those stakes in. If those are just straight driven pins, which those particular ones are, but if it's a gravelly surface and they've had to bash it in and they've wiggled it down, that's probably got no tension at all. So ensuring that your ground conditions are good for your stakes is absolutely vital. And as I say, I'm not going to go into that in great detail because I believe that they're doing a session on that tomorrow. Okay, here's another style. So this is a water ballast of one sort or other. This is from, well, Big Round Bush. This is a stagecoach system, and they have designed their bases for their towers to hold the water in them. Okay? They know how much water can go in there. Their engineers are happy that that is adequate for it. But what can go wrong with this? It can leak. Evaporation, absolutely. Stick it out there in very hot weather, leave it there for a week, and your water's going to start disappearing. Your tower's still there with all the weight on the top of it. Yeah? So make sure, as part of your testing regime, or your inspection regime, that somebody's checking that that water's in there all the time. Plus there's actually also, if it's there long enough, there's all kinds of environmental hazards, but I'm not going to go into those at the moment. Okay, here's another style of water ballast. Okay, so this one is a photo, an IWB, but that one in specific, what's the problem with that one? Thank you, I'm going to pick that one up. Shh, don't look at that. Forget this bit, but what's the problem with using them? Black one like that.
It's got an empty tap on, very easy one to do.
Yeah, there is one to do. You've got no idea how much is in there. I've got no idea without actually taking the top off and sticking my hand in. Yeah? Kick it. Yeah, good do. Good over your toe. But as you rightly say, that's the biggest problem I found with that one. So that's a close-up of what happened to that particular structure. Now, what's the water ballast there to do? Stop uplift, yeah? Now, is that diagonal on that very small piece of truss, do you think, designed to take upload? I'm not an engineer, but I would suggest no. And with a nice, neat steel hook with a 5-ton ratchet strap over there, what's the first thing that's going to go is you're going to tear that strut out of that aluminium piece of truss if you get a big uplift in it. The 1-ton ballast will stay on the floor, the ratchet strap will be fine, but the truss will be lifted anyway, and then you've got back into your same problem. You've got a roof that is unstable. Okay, so there is a number of factors, and again, IWBs are something that, going back to SCOS that was mentioned earlier, part of Alistair, who runs SCOS, also sits on the AGOS, and last time I met him, he was talking about putting a document together all about the problems of how people do ballast. And they are great and convenient pieces of ballast if used correctly. If I go back to that picture, this one hasn't, to be fair to them, but how many times have you seen the strap across that top? You know, it's been pushed through there and around there. Again, the frame is not what gives it its strength. It needs to be fair to these guys, they have gone right to the way round the bottom. Yeah, so at least they are using what they are assuming is a 1-ton weight if they filled it up to actually hold their stage down. There are, again, it's not perfect, and as we've shown, they've got a fundamental flaw in how they're connecting it to the whole stage. I mean, this is not a great example, but I was just picking it out because I thought it showed the picture quite well of what was fundamentally wrong with it. Another method, sandbags. Yeah? But, you know,
Simon, there's no doubt that ILBCs like that are designed to take that load.
Right. So it's just about how. But again, what's the weight in the bottom of that? And there's another one for you, which I'm going to ask the question in a bit about concrete. But the weight of that, I tried to do some research, or did do some research into how much a cubic metre of sand weighs. Anybody want to give me that value? Thank you. There you go. Is it wet? Is it dry? So when you put it in there, it might have been wet. If it dries out and it's sat there for 2 weeks and it's dried out, is it the same weight? No, it's not. And if it's leaking, if it's a porous bag. So I'm not saying that these are wrong. I'm saying these are the kind of things you need to be looking at, and you need to be able to justify why you've used those. You know, this particular example, I believe, is probably because it's sat on a beach, I believe. So, you know, sand was probably a quick and easy way of getting ballast. Okay?
It's better to use gravel, actually.
Better to use gravel.
Well, it's a constant weight.
It's a constant weight. Yep, that's fair comment, Steve, absolutely. Here's another one. I was trying to find, as I say, and I was going through looking for the concrete ballast ones, and there we go, I've got a concrete ballast that sat on the legs of that. This one is not a particularly good picture, but I couldn't find a brilliant picture of concrete, although, again, it must show that I am actually, well, particularly us, we're not that sad that we go around taking too many pictures of concrete. But there were a few, but I found this one in the corner of here on a structure. But there's a different sort, okay? Again, slightly odd, but this is a concrete and steel structure. It has bars driven into it. It has a threaded bar that goes up and holds in a plate across the top. Looks a bit odd because of all the feet. I'm not quite sure why all the base plates were put in. But actually, this weight is a one, it's got its fork boxes. It's a good piece, and it's designed so that you can move it anywhere within it. Okay? Actually, quite a clever lump of concrete, I should probably call it. Okay, so those are some of the kinds of ballast that we come across. And again, I am not saying what's right or wrong. We need to have it, we need to ask the questions though when we're out on site. Why have you done it like that? Is that safe? What are you going to do about managing it? How are you going to make sure that somebody hasn't punched a hole and taken all the water out of that ballast? Yeah? So that might take a regime of inspection. Oh, and here's my last one, which, again, this is the end of, you probably all see, this is a running gantry, a finishing gantry. So I put at the end of my ballast any other things. This is what this company's decided that they're going to do it with. You know, adding up the weight of all those things, all those rubber feet, which are off the thing, I'm sure probably, I'm still not quite sure, they were probably meant to be concrete feet, but the weight, knowing the weight, so going back to my engineering caps, when I get to the engineering caps from the people who built this gantry, it says there has to be X number of kilograms on the feet. That's the piece of information that I need, because then I can go along, and if it only needs 50 kilos, and I go along and say each rubber foot weighs this amount, I can count them up and go, okay, you've got the right amount of ballast on the bottom. But if I've got to search through 20 pages of engineering calcs to try and work out what the reaction force is and how many kilonewtons there are and all the rest of it, I'm going to be scratching my head. I'd much rather it just says on the bottom, you must have X number of kilograms. And again, I know engineers work in kilonewtons, but us people, ordinary people, tend to work in kilograms.
Warren,
Yes,
just a quick one on that picture there.
Yeah.
It shows you the weight, but it doesn't actually show you where it should be. A good engineer would actually show you where the weight would be, and I bet it wouldn't be spread out like that in a lump.
Thank you. That's another fine point. Okay, so there's a third thing that we need added, actually, to our list of useful information that we can have from an engineer, is where exactly that reaction, that ballast, whatever it is, needs to be. And I know that you know, we did some work with Steve with saddle span tents, because I'm sure you're all aware there was a bit of a hoo-ha about saddle span tents, and Scott's released things, but you know, there's a load of engineering about saddle span tents, and exactly about the question of when the guy, where it needs to be, at what angle, where it needs to be off the front of a saddle span tent to make sure that it has its correct reaction force to stop uplift. that information is there. It's been done by the designers. And you know, when we all went to them and we've spoken to the engineers, they said, yeah, it needs to be there. I mean, now you've got a great piece of software that could say, actually, okay, well, if I move it 2 meters to the left and 1 to the right because I need to get a burger van in, what uplift do I now need to account for? Or what am I doing to the structure? Okay? So, that's ballast. I'm going to ask one simple question, and that is, well, there you go. I'm giving you 4 answers, and I know for all the engineers in the room that there is different weights of concrete, but I am talking what is taken. I can't remember what British standard it came out of, but the standard for concrete design. So, first, A. Who wants to put their hand up? Who thinks a cubic metre of concrete weighs 1.7 tonnes? Now, they're all looking. It's correct. 1. Anybody else? Okay. 2 tonnes. Few of you? You should know. 2.4 tonnes. Ooh, looking good. 2.8 tonnes. Okay. Well, you are right, according to the British standard, and the average you use for a standard concrete is 2.4 tonnes for a cubic metre of concrete. That's when it's a cubic metre, not when it's had all the tops knocked off and the bits taken out the bottom and all the rest of it. So a cubic, you know, I've been told, oh, that weighs that much, and it's like, well, actually that's not a cubic metre anymore. That's, you know, it's had half the top chopped off because it fell off the back of an artin at some point, yeah? So a full cubic metre of concrete you can allow for on a ready reckoner to be 2.4 tonnes. Again, as long as it's not a special lightweight concrete that you decided to use, just to try and reduce your trucking costs. But it was an interesting question because I wasn't sure, and I went through a lot, and it just goes to show the power or the weakness of the internet, and that you put it into the internet and you can come up with about, well, an awful lot of different answers, and certainly never believe anything it says on Wikipedia as far as I can see. But I did find somebody who seemed to have the right answer and cross-checked it back to a British standard, and that was it. Would I be right? Would you say, would you take that as a good average for a cubic ton of concrete? Cubic metre, sorry.
Yeah.
Yeah.
If it's a big chunk of concrete on its own, it depends again where it's made, because the aggregate weights.
Right.
So it can vary between 2.3 and 2.5. 2.5 if it's full steel.
Right.
There's lots of steel reinforcing in it to make it stay together as one. 2.3 is just a lump of concrete. So
if we allowed 2 tonnes as a safety officer, and you saw a cubic metre of concrete, and you said that's good for 2 tonnes, you'd be pretty safe, wouldn't you? Yeah. Okay. I put this picture in because I love this picture. It's not one of ours. It was sent to us a long time ago by somebody. But I always think that this sums up, you know, some of the things that I've said about things being straight and you know, level. And when you look at this picture, well, it's just got so many things wrong with it. It's a marvellous picture. I was informed. I mean, the whole story was they didn't actually do the gig on the stage in the end. You'll see, all the crew had set up all the drum kits. The whole thing had been set up. Yes, this is the sea, and that's the high tide mark. But I think that this sums up what's wrong. And again, this is, to be fair to it, is quite an old picture. And I would like to think that this doesn't happen anymore, but maybe I'm just being ignorant, and the kind of clients who build like that don't pay for our services. I'm going to do a very brief bit on the effects of weather, not about, I mean, I was really just trying to pick up on a few points and come to where they came from. And as I say, wind, I think wind we all know about, and I'm not going to go in any great details. We know what the wind can do to structures. Rain, what can rain do to structures though? It's a different one because you might not necessarily think it's such a dangerous thing, but what's the biggest problem with rain and structures, certainly in my view? Anyone? Sorry? Absolutely, yeah. So all those, like we showed, those beautiful free states, if it rains hard enough and it's, you know, that kind of wrong kind of soil, you'll just be able to pull those out with your hand, and then your tent isn't safe. Rain, it also, when I built, I remember building stages, and again, it's not a direct structural failure, well, it is a structural failure, but being on a Michael Jackson stage, and I remember we had a large tarp over the top of the monitor desk, and it filled with water, and then it ended up on the monitor desk, all of it, because it just ripped the tarp in half. There was such a big thing in there, and it rained overnight, and it destroyed a monitor desk just before a show, which didn't get us very many brownie points, I seem to remember, Jumbo. But it's, you know, rain can cause that kind of structural damage in fabrics. As Rudi said, you know, a ton for a cubic metre. And a cubic metre isn't actually that much water when you see it. See the IWBs, you can get that inside a tarp quite easily. But if you get across a seam and it's not very good tarp, it will split. And then the sun can do the same thing. It can dry the ground out. Yeah, just the same as it does through electrical. And when your earth suddenly disappears because you're in dry clay and your earthing rod is now not making any kind of electrical resistance. The same with the sun. It can dry the ground out. If you've got heavy clay soils, you will get the pins will just start popping out. They don't have any structural stability anymore. So what should we be doing? We need to look at regular inspection after I put adverse weather events. We should be watching the whole time. How is the weather affecting our site? Therefore, how is it affecting our structures? Yeah, they need to be keeping an eye on that all the time. Going along, Tim's favourite term about tyre kicking, you go along stake kicking if it's been too sunny, which is not a problem we seem to run into very often in the UK, I must admit. But, you know, the ground drying out and kicking that pin and it just pops out in your foot, you know you've got to get something done about it. Yeah? Getting the tent people back in again to make sure that their tent is safe. To do that, you need what is often termed a babysitter as an on-site crew member. Having that person there is vital if you are having big structures that are going to be managed, or you are using managed wind turbines, because you need somebody competent to do the tasks that may be required in your wind management plan, whether it's a blowout panel or whether it's a panel you've got to pull out yourself. Yeah? Having a babysitter is vital for any site, in my view. And the people who turn those down, and it might seem like the guy's got an easy time and he's sat there on his butt doing nothing, but when you need him, he needs to be doing something. And if you've got a babysitter on site, give them something to do. Give them a checklist, or rather ask them to make sure that their company has given them a checklist, so every day they go around and they inspect their own structure to make sure that the lampies haven't taken out all the diagonals to stick their dimmer racks in underneath the stage. Yeah? To make sure the tent poles are still upright, to make sure, you know, there is no damage to it. A truck hasn't run into the back of the stage. Use that person, get him to do a regular daily inspection sheet, and that can all go down as part of your safety documentation, your safety processes, to make sure that your temporary structures are being managed correctly in a real time. There we go, see more we go, just for a laugh. And then the last, I believe this is my last one, pressures on build. So this is more about the safety of the crews building the structures rather than the safeties of the structures. And again, I do put those in two different terms. I know there's been a lot of talk about the HSE and codes of practice and enforcement. You have to remember that there are two distinct parts of a temporary structure. There is its structural stability, and then there is how you build it and take it down. The structural stability is vital to make sure it stays up in a wind, to make sure it stays up if something's happening to it, and it doesn't fall down on people. Then, some poor buggers actually got to build that stage. And that is what the HSE are looking at when they're coming to inspect our sites at the moment. They won't be asking you most of the time for all your structural calcs for your building. What they will be is they'll be looking at why you sent someone 30 foot up a pole when there's a cherry picker sat 5 feet away. Oh, because I can't reach the nut and bolt I need to reach from the cherry picker. And that comes full circle right the way back to the designer. The the designer, as was shown in CDM, has a responsibility to ensure what he has designed is safe to build. So making sure that when your designer has designed you some marvellous structure, but it's going to cost 10 people their lives to build the thing, it's a fairly useless structure. Yeah? And I know in the construction industry they spend a long time doing that. And a lot of our temporary structures still come and are still being used from a time where that thought was not necessarily in people's minds. Yeah? Or in the designer's minds.
Sorry, what's on that? You know the picture you showed earlier with the water ballast, you know, the stage system on a steel deck or a hanger deck type structure.
Yeah.
But there you've got three different elements that are all structural, that are all come from being matched together.
Cobbled together, I think would be the best term.
You've got three designs between all those three products. One's being used for something that's never designed to be used, which was ballast, and the other two are being used. They're designed to be put together.
Yeah.
And there you need another design really to show all those three things together, working together as one new structure. And that's what we don't see. I see on site quite often as a safety point of view, I've got design element for the roof or the structure sat into something else. It's a separate structure. It's got its own characteristics, both of them. It doesn't have to marry together with it. It's just something.
I totally agree with you, Jake, and I think that is one of the bits. We got involved with one of our clients earlier who came up, who was up in Scotland, internally, funnily enough, in the SEC, and they phoned up in a bit of a panic because the building inspector, and as for any of you who are Scottish in the room, or if you work up there, you know that there's a Section 89, which is a much more stringent control, shall we say, than we have in England, and in Wales, actually. England and Wales are the same. I'm looking to my colleagues there. But the Section 89, and they were building an indoor stage, and the person from their inspector from the council was not happy with the fact that they were using a proprietary decking system that had been designed by an American manufacturer, and they were quite happy with that. But what they didn't have was a design for the way it had all been put together. So the piece of decking on its four legs was fine. What they've done is they've put it together in a configuration and put something else in here and something in there, and there wasn't an overall design for the whole element of that touring production. And so they had to go back and try and get it engineered. The company involved tried to get people, but it was a bit late. They got away, well, they didn't get away with it, but they got it through. But that was exactly that problem, in that there was a number of different elements that had been brought together, and no one engineer had then looked at the whole of that. So
I think as well on that case, sometimes like it's very like it's safe, it's been thought about, but there isn't the support paperwork that somebody competent has or experienced workers. But
and to be fair,
that always bad practice. It's not very good, but you do need the paperwork.
I think that's the danger that also comes from modular structures, because although modular structures are designed to be separate, often the modules that are put together are not the ones that are designed to be working together.
Absolutely. I mean, and these are all fair points. And in that particular case, it was an American company who brought it over. So they had problems because, you know, again, they were not used to that idea. So when we said to them, you've got to have it engineered, they were just like, what do you mean? What's that about? You know, we do this all the time. We've had it out for 6 months in the States. And it's like, well, yeah, but we're asking you. And, you know, so you ask them the question, you say, okay, fine, you've had it for 6 months in the States, but has anybody actually looked at it and told you it's safe? Well, yeah, we all think it is. Fine, you've got to get it all into German. Yeah, you've got to get it then into German and everything else. So there are a number of different, you know, elements that will come in. And as I say, I think for me, going back to where I was trying to go with this one, is the time and time again, as pressures are built, that's about your crew safety. Because the promoter doesn't want to pay for the stage or the stadium for an extra day, so you've had to go in and do it overnight. You know, it's time your crew are tired, that's when incidents and accidents happen. If you've got good procedures, you've got good things in place, it's not quite so critical. But you do need to take care of and ask suppliers, it doesn't matter. We've all heard those kind of pressures. And that, to me, is a really critical safety part of any job. Because you need to make sure you've signed it off before you get the riggers into the structure. Yeah? As we were talking about, it was about the, how safe it is when it's halfway up. Is it safe to build in it when it's still halfway up? I don't know. I can't tell you. Hopefully an engineer can tell you, but you should be asking people, giving people enough time to build a structure so that it then can be used safely by the next set of people who are going to use it. Because we don't very often build temporary structures that then don't have anything happen to them. There's going to be lights, there's going to be deck dressings, there's going to be stakes, there's going to be sand, and finally there's going to be the public. Yeah? And that's the end of my little bit. And there we go, another somewhat odd temporary structure. But again, a temporary structure, none the same, beautifully being used by cherry picker. So that's my little spiel. Again, open it up to questions. Any questions? I see Jumbo, far away.
Barney, if you go back to your second to last picture, showing the base, jack right up. That one there.
Yeah.
You was going on about crew bosses signing off, right, as built plans. You can guarantee that is not an as built plan. Would a crew boss sign off? That's saying that Graham's run out by 500 mil, roughly. From the drawing.
Sorry, yeah.
Why is the guy going to sign off for something which isn't drawn? That would be his reason for that.
But a good sign-off sheet should have scoping it where you can write a deviation, and you want to have the deviation checked through for a phone call, going back to the drawing office. So you could say that it's been followed through and they were safe to do that. So then they can sign off. But you don't sign off as per drawing with a deviation, you declare that as a deviation, wouldn't you?
But you try and go back and draw that on a CAD. You will not do that.
I'm not saying go back and draw it, but what the crew boss doesn't want to be in a position saying that's right. What they would say is, I'm signing off that we've done this deviation, and I phone my office, I've got evidence somewhere that my office said that's fine to do that.
What you can't do on the CAD is work out what the slip factor is between the plates if there was any lateral loading. And that's the issue I have with that.
Yeah, I'm not saying that's right or wrong. I'm saying
Nothing wrong with it being incompressive, but what if it's a live load?
So what the point I'm making is the crew boss can still sign off, declare a deviation, and make sure it's not his responsibility to say whether that's safe or not.
I tell you what,
There's another method there. I mean, this one, again, the one thing it has got is, I picked these photos out because they showed a bunch of things, and I knew that they could all get, most of them could probably get torn. But this one here, the one thing I will say is that, say, with this threaded bar that goes through this I-beam, you are holding it in compression, in whatever, so you're actually holding the base to the tower. I cannot remember why those are there, because I can't remember which site that was on.
I bet you can guarantee why, Barney, because you're one of the 500 mil piece of tower, but in between the base and the tower to get it to the right.
There's the practical side. Well done. That'll be it. But yeah, and it's it's not ideal. I like the system that it's sat on. I like the fact that you can tie the base to tie the base of the tower properly. I think that is well designed. In this particular way they've used it, is probably not the best way. Anyone else? Yes, Steve.
With the sign-off, it's lots and lots of structures, small to medium structures get left on-site with the responsibility of the client. Often the client's not prepared to pay the base. So I think in those sort of circumstances, what needs to be emphasised a bit more is that there's no emphasis on what the
about cooperation, coordination. I'm not out to try and get them. And one of the bits I really dislike about the construction industry and why I don't want to go down that particular route with our industry is it's so adversarial. I happen to have one of my really good friends as a construction lawyer. She drives around in a much smarter car than me and lives in a much bigger house than me because she makes a fortune of construction contracts because they are solicitors and that's all they do. And she sits there all day long finding, well, you've used that bolt instead of that bolt. So if that's a change to the contract, wait a minute, you made me wait 10 minutes for a phone call to make that change on our plan. So that's more money. And if we get to that stage where we are actually run by contracts, which is where the construction industry is sitting, we've all got a lot of trouble. And again, what you've just said, Steve, is much better, and is, I think, to be fair to the HSE, what they want when they talk about us trying to do it, it's not about a paperwork trail, it's about making sure it happens. So, vital that the supplier sits down there with the client, and as you said, goes through the wind management plan, not in some massively complicated room, but goes, this is what you need to do. And we keep talking about the wind management plan. What do you need to help you run a wind management plan?
Measure the wind knowledge.
Yeah, an anemometer. The client hasn't supplied one. The supplier hasn't supplied one. How do you know what the wind is? Yeah, my trousers are flapping a bit. Is that 10 metres per second? Is that 20 metres per second? Or it's because I'm in the toilet and it's even worse.
We need the toilet sets. I just do a bit of sales. You bring them along.
We bring one with us, exactly. Well, we do, and even if it's not a proper one, I have a hand. We have little hand ones that you take. You cannot have a wind management plan on your temporary structures unless you've got an anemometer, because it means nothing. Yeah. So, and to me, if I'm honest, as a safety officer, although we carry some with us, I would suggest that it is the supplier's responsibility to provide an anemometer.
CDS does say that every structure should have one.
Yeah.
And not only should have one, it should be able to record wind speeds throughout the film.
But interestingly, TDS doesn't say whose responsibility that is. It's the one thing it doesn't talk about. Because there's a whole list. I mean, let me just quickly rush down here and pick up TDS. I'm trying to make a sales pitch for it, but the most useful document for any of you. I mean, hands up, who knows this document? Who's got this document? Great, good. So we are the enlightened sat in the room. But on page 31, there is the who's responsible for what page, yeah? So, I can't even read it, the answer goes so much. Client's requirements, site location and event, design. So it's the clients to measure the ground bearing capacity. So if you're the supplier, you've got every right to go, well, not right, but you should be asking that question of your client. Say, what ground is it on? What's the ground load bearing pressure? What's our state? Have you done a state pull test? And I know for not at the back, one of the things that Tim's talking about, at all your sites now, you carry out a state pulling test. And then doesn't have to be thousands of pounds worth of testing. It's a dynamometer and a forklift, or a JCB. You bang a pole in and you see how much it takes to pull it out. That didn't take thousands of pounds, but it gives you an idea of what your ground, not your ground bearing pressure, that's certainly your state pulling, so it's the opposite, but it helps. You need to know. And again, it doesn't mean you have to go and get a soil survey company that spend thousands of pounds to have it done.
Sorry. I was just going to say, as you pointed out yourself, the ground conditions can change there, so obviously that's like an indication.
Absolutely it is, but it's a good start, isn't it? If you don't know it at all, you don't know where you're going. So
I think it's actually quite difficult to insist that all contracts supply an honest because you get to start that with, or any large site market, you've got 50 or 60 different temporary structures, all with an monitor, where actually most of the problems you get with wind at festivals is you do particularly those with terrace and stuff like that, and tin holding, and surely I would have thought as a duty care, the promoter should have overall responsibility knowing what the wind conditions are on site.
I'm sorry to interrupt, but we have run well over on our tea break. Martin, would you just let them them know out there that we are coming out for the tea break?
So,
Would you mind?
everything's out there and it's
You sure?
so fine, yeah.
I was going to say, there's no reason why we should, rather than the tea and coffee going cold, there's no reason why we shouldn't carry on this for another 10 minutes after the tea break if you want. A lot of what we were going to do in the next session has been covered in this one, which is why I've let it run on. Do you mind if we break and if necessary we'll get you back up, Simon, if necessary. So I want to thank Simon very much indeed for doing this. It's been very, very good, very clear, very concise. Thank you very much, Simon James. Tea and coffee is ready outside. We've got 15 minutes and then we'll carry on. And as I say, a lot was from the next session was covered in this one, so it's not really hard. Sorry, Simon, I just wanted tea and coffee going forward, that's all. Okay, that's a bit better. I've asked Simon to come back up because we were going in full flow and I want to apologise for interrupting him, but I didn't want the tea and coffee to get cold. I really think that there were some questions that still needed answering, and I've asked Simon to come back up for another 5 or 10 minutes. So if you've got any more questions on this, please fire away. I had a couple.
That's what I do, so I'm on all the sites that we go to, obviously they have that, but there's also quite a lot of other safety professionals in this room who I work with and know, and I honestly don't know, because it's one of those... It's compulsory at this stage. No, it's not compulsory, and looking back to the CDM model, which again was ups and downs, the model that we actually like and I think is a good model, but I run a safety consultancy, so as Alan said earlier, I have a vested interest in making sure it's, that I keep working. And the CDM model has this person called the CDM coordinator, who is basically the safety person who acts as an intermediary between everybody. If it does work, as we say, we know it's not going to get enforced as it is because it doesn't fit our model that we work in. But there could well be the answer that requires a safety person on all event sites. Now, I would suggest certainly all of the big promoters, the big festival organisers in this country, certainly all have somebody like myself or a similar ilk on their sites. I don't know any of the big festivals that aren't. To be bluntly honest, if they didn't, we'd have gone and sold our services into them by now, telling them to help. But there's other markets, in Europe, they have, we was talking about the Bauer book. One of the interesting things they have in Germany is they have this, they have to have an event. They have this guy called, is it Stagemeister?
The
Bühnemeister. And they are making it a legal requirement. If you organise a festival, you have a big event, you have to have this Bühnemeister there. And this Bühnemeister is trained specifically to be a safety person who has a specific role within the structure of how they set up events. And it's much more of a technical role, I'll have to say, because bad example, but Love Parade was obviously a good example of where they got it horribly wrong in Germany, and maybe if they'd been using different models they wouldn't. But there is different structures around the world that are setting them up. But within the UK, I don't know. I mean, I would say everybody in this room who, as I've said before, we've got the enlightened in this room anyway, because they're at this seminar. Everyone
method of applying the things we've been discussing today for event management and structure safety, because I said it earlier on that major events like, you know, the V festivals or Tea in the Park already undertake most of those procedures that are asked for under CDM. Not all, but a lot of it. They're a long way towards it anyway. It's when it filters down to the small events, the local motorbike rally, and they use the bikers for security. And that happens not far from here in Sheffield every summer. Been happening for a long time. But at that level, there is no guidance that says you should fill this bit in here and you should do that there and you should do... Now some local authorities have started doing it as part of their licence application, and that is a good model to start with at the lower end where they can't afford an event safety consultant.
But it also stems back, I guess, to education and some of the police are coming out. A lot of them actually don't even cover the elements and don't cover the ideas within it. It's all theoretical. So-and-so said this 20 years ago, whereas we know the event is moving so fast. But when you're looking at stuff that old, it doesn't equate to what's on the ground now at all.
No, and I agree. So it's, you know, education is an important part, and more there's lots of courses out there that are, he's looking at education, that are out there that are teaching people, and it is vitally important that the people who are growing up, who are going to come into the event industry, it's like, you know, as I showed at the beginning laughingly, I fell into this industry. I love it, and I've now been working in the event industry for almost 30 years, and it's what I do. But when I started, as I said I was going to go away for a year to have a laugh and then go back and get a real job and be a civil engineer. I never quite made that jump back again. But there are people now, there's lots of young people who are out there on university degrees who are learning, who are going to make the event industry their profession, their livelihood. And they do need to be taken in, and it's not just can you do a risk assessment, it's about the structures and how management works and how that feeds into everything. And a safety officer obviously has a role to play within that. And you know, we act in different ways for different clients. You know, being a safety officer can be a great job sometimes, and it can be an absolute nightmare others, depending on, you know, your clients, what the job is. You know, I don't like staying awake all night scared and stupid that the event that I'm actually working on is going to go wrong. But sometimes it happens, yeah, and I'm supposed to be the one who's making sure it doesn't go wrong, but that doesn't mean that you have the ability to do that all the time. So structures, you know, there are big ones, and I have to say that most of the time, I'm glad to say that certainly on the sites I look at, I'm not likely to run into an Indiana, because I won't ever let that happen on my site. The structure might fall over, but there won't be anybody underneath it when it falls over, which is their big mistake.
Can I go back to the animal water?
Cool. Absolutely. I'm obviously getting a here, Steve, but carry on, absolutely.
I mean, surely it's a very basic risk assessment done by an organiser would go to the conclusion that they need to know what's happening with the weather on site.
Okay, I agree with that, and yes, as I say, on the bigger festivals, it may be that it's a central event control function.
Yeah.
However, if you are giving your structure to a small community event and that's the only thing, do you think that's different? So maybe we need to...
I think it's horses for courses, but
I
think the default setting should be the organiser who of an event should know what the weather is. Because even if you do supply an monitor in your structure, who's going to read it? The monitor engineer, drum tech, stage manager? You know, so there might be someone who's competent in there to actually know what they're looking at.
The drummer.
Yeah.
You run out for 10 in the morning when
it's like, that's a, you know, like, it's not always, you know, someone's not going to be looking at it 24 hours, so technology's got a part to play there.
I do agree, and there are different ways. I think horses for courses is the right way. Sorry, Brian. I'm aware that obviously nobody can see behind him, and Brian's had his hand up over there for a while. I'll just finish this bit, Brian, and I'll come straight to you, I promise. And yeah, maybe it is, but what I would say with the supplier is that they should be checking. So if you go onto a site and you go to, you know, you're putting you're putting up one of your structures at Glastonbury, you know that there's a big enough management system, safety management system, that they will be there. But it should be your responsibility to check that that person does have the ability, as part of your instructions to them, when you are handing them the wind management plan, you know, question them beforehand. Are you going to have an anemometer? What's one of those? then you have to start alarm bells ringing, or even just telling them what their responsibilities are.
In terms of how are you going to monitor the weather?
How are you going to monitor the
monitor what's coming towards you in the next half hour?
Yeah, absolutely. Okay, so Brian.
Well, the flip side of what you're talking about there is that anybody, absolutely anybody, can call themselves an event organiser or an event manager. There's no fit and proper test for an event organiser. So morally, suppliers should be doing the best they can and presenting the best information that they can anyway. With community events, surely some of the big fat cat safety companies should be giving some free advice out. just a little podcast.
I'll tell you a small story about the last time I gave any advice to a community festival. It hasn't ever happened again since, which is to my horror. But yes, I think you're absolutely right, Brian, about the event organisers. The same could be said for everyone, and I think we talked about confidence. Sorry, I will get to you. We talked about confidence earlier, and something that CDM talks about, and I do like the model. Again, I keep referring to this, but CDM talks about competency, and it's designed to ensure that large construction companies who have money and are spending it to ensure that they are training their staff, not just buying themselves a bigger Mercedes. Yeah. One thing our industry is not necessarily good at, because we are so seasonal, and this is, I see, as our biggest problem in our industry from a training perspective, is the seasonality of it. Large structures companies will probably be working, the best they'll be working is 4 or 5 months of the year in the UK. After that, there's bits and pieces, but that's it. So the question I always heard, or the answer I always go back to, let's train the people, is like, yeah, but I can't train them because after 4 months they'll bugger off and they'll go and work for somebody else. And as an industry, we've got to try and grab that and ensure that people are going to train things, and that there is routes that people can go through to train, to make sure that that crew chief who signs it off is confident. And that doesn't mean I want him to spend 2 years at university, but the NVQ route, that type of route, is all there designed, and there is lots of stuff there now that is designed to try and make sure people are confident. I spent a long time working with Plaza, working on the Plaza rigging certificate, which is a competency, it doesn't say you're a rigger, it says you have passed these competency tests. You haven't stopped learning, you will carry on learning as a rigger, but at least it gives a definition and a start to what we need to do. And staging companies, especially, because we are asking these guys to do some fairly difficult and possibly dangerous things at times, needs to be looking at that. And I don't just mean the large staging companies, the structures, teams who build marquees, etc. I believe need to do actually have the NVQ2 route, but those kind of things, and I think that's something we should take away as well, is how we're going to try and train people to prove to the likes of me that your crew are confident. I ask, one of the things we ask our suppliers is, can you sell the training records for your crew? Yeah, we get mixed responses, shall I say, back from that one. So, gentleman at the back, you were...
Yeah, really just a practical point for those in the room who hire out stages. You need to consider whether or not your insurers will meet a claim. Firstly, if your stage is damaged and you don't have crew present, but more importantly, will they meet a personal injury claim? My understanding is that the festival organiser will be the first stop for a personal injury claim from a customer, but they might then make a counter-claim against you as the supplier of the stage if they think there's an element of malpractice, neglect or incompetence there. So if you don't leave a babysitter on site, you need to ask yourself the question, are you insured as a business?
Yeah, I mean, luckily I'm not a supply company, I don't have that thing, but insurance is a whole other world that we could probably spend a whole week talking about as well. I agree with that, and it's certainly worth checking, whether your insurance does cover that to supply. I mean, babysitters are an emotive thing because it tends to be the supply company who doesn't want to pay for them, it's the client who doesn't want to pay to have somebody, in their view, just sat there doing nothing for a week or however long you're on site. So I do see that, certainly, the large sites, again, the big festivals will always have somebody there, but the little ones not necessarily, because it's expense. And, I keep coming back to this, everything's expense at the end of the day. Promoters, much as I knock them and give them a hard time,
Okay, thank you very much. You've ended up doing way more than we asked, but it's been absolutely wonderful. So let's hear it again. Thank you very much, Simon Bailey. Right, well, we're heading into the last lap for today, and this section is on installation procedures. Initially, time it up. Okay, first thing I want to show you, this is a picture of Glastonbury in 1970. Building the first scaffold pyramid. The second pyramid was made out of telegraph poles. We mentioned about using materials for erection that weren't intended. And I'm minded of a famous quotation by Buckminster Fuller, who was supposedly the inventor of the geodesic dome. And he said that a piano top, if you are shipwrecked, makes a very fortuitous lifeboat. That doesn't mean that the best way to design a lifeboat is to use a piano top. And telegraph poles can make a cheap alternative to proper structures. That doesn't mean the best way to design a pyramid stage is to use telegraph poles. Let's have a look at the picture of Glastonbury today. A vast difference. So we've been talking about all the potential problems here and the potential for harm and hazards. And tomorrow we're going to go more into hazard and risk and the differences between the two. We're going to go into erection procedures. We're going to have a whole session covering anchors, guying, and I've written some notes down following Simon's slides, particularly about the one with the ratchet on the halfway up the truss leg, and explain to you why that actually can induce failure all on its own, let alone providing an extra level of safety. Sorry, I'll stand up. Sorry, guys. We have, put another one on. I don't know if this is set to cycle through. It is, I'm sorry, I forgot to reset it. Once again, this was from a sparsely attended, by the looks of it, free festival in the 70s. God knows where I dug this picture out, but I think that was me that, no, I had an Afghan in them days. But if you see, it's a basic scaffold stage with minimal bracing. The industry is inherently safer by a factor than it was 25 or 30 years ago. We don't want to let all this get to us too much and say, well, you know, everything's wrong and it's doom and gloom. And yes, we had this major issue in the end of July, beginning of August of 2011. I call it the annus horribilis for the event industry, and it was, and it is. But let's not forget that the industry in itself is inherently better than it was many years ago, and that the safety record of the UK events industry is very good by any standards. Plus, the event industry in the UK is probably the most wide and varied of any country in the world. Something to do with Englishmen and not being out in the midday sun and being out in the midday rain, I think. But you go, I mentioned it earlier, point to point, motocross, scrambling, you name it. Thousands of different events every weekend up and down the country. It's a rich and varied business. And the structures are rich and varied. We've been talking about some of the major ones. Not everybody has major structures. I think as a recap, we should always be aware that nasty things can happen. And to say that something like Puckle Pop, and I was asked what Puckle Pop was, I'm surprised that what happened at Puckle Pop briefly and this is to my best knowledge, I'm not an expert on what happened at Puckle Pop, but there was a line of trees which were uprooted by the high winds and collapsed against the stage, which caused the stage to fail. There was another structure which collapsed and did cause terrible industry and deaths. And then there was a big top. And the reason for bringing this back up and mentioning it, we mentioned that a couple of £100 cables might have made the difference with Indiana. There are videos, and by all means feel free to have a look when you get home, of Puckle Pop on YouTube, and they're quite graphic. There was a big stewarding issue there. This is not a structural issue. Is that while all this damage was happening and the panic, people thought the tent that was collapsing was a safe haven and actually ran into it while it was collapsing. And if you look at some of the video, you will see that one of the 6 king poles on the big top stayed up. And the time it stayed up, 1,000 people got out of that tent. 1,000 people got out. I mean, some were killed when the first poles went down. But the fact remains is that one king pole was held up with a 16mm guy. And by one anchor. How it stayed up, we don't know. And it's quite clear looking at the video that there's not much there holding it up. And the question that I ask is, shouldn't we be putting extra anchors on to allow for that kind of eventuality? Now, in exhibition halls, you have fire safety systems. And in theatres, you have safety slings on lamps so that nothing falls out of the sky. This is nothing to do with the structural performance. This is to do with external influences that may affect, but to provide an extra level of safety. So what I'm saying is, there are some very cheap things that you can do. There's a lot of very expensive things you could do as well, but very cheap things, particularly with big tops and ground support stages where extra guying would do an enormous amount of work for not much money. And I was asked in August how much it would cost at a major by a festival organiser, how much it would cost for a major festival, let's say the Festival Reading Tea in the Park, to implement those kind of extra safety features on the stages. And we worked it out, and we didn't think it was more than 0.1% of the turnover of the festival. And that promoter said, if that's what it costs, do it tomorrow. So, if it is such a small amount of the turnover, 50 million, I think Reading has been, the economic impact of Reading is 50 million, something like that.
Sorry, it's a bit small than that.
Is it?
I'd like to say it's 50.
I got those figures from the local authority, and they said with the hotels and...
No, we commissioned a survey, it's about 30 million. It's
oh, right.
The annual impact of it.
Right, okay, well, I don't believe what I read in the papers, sorry about that, but no, it's still a lot of money, 30 million. And
that's going to be 70. That's
yeah.
That's going to be 70 million.
So what we're saying is 0.1% is actually quite a bit of money. Not really going to impact the bottom line for the festival organiser, 0.1% of their turnover. So maybe all the contractors, sorry.
Really sorry, the economic impact of the festival is 32 million. It's not coming into the Festival Republic.
No, yeah, this is hotels and petrol and people eating in town and restaurants and that, yeah. But even so, 0.1% of what the festival does have as a turnover was not an enormous amount of money, but it was enough to make extra effort, let's say on big tops, let's say on stages, particularly ground support, I think. The hoop stages, and I mentioned this briefly earlier on, where you've got this hoop, like we showed on the analysis example earlier, you've got this situation where the sheets are sliding into a frame that's already stabilised. With big frame tents, you have the same thing. With big tops and with ground support, even if the masts and everything are guyed down to an adequate amount, for example, ground support stages, there's a point halfway up, even if you do guide the masts, the uprights, where any wind loading on it could actually break the uprights and cause them to fail. You could just shear at the connection or whatever. And whilst it's not dangerous, it is a peak point to be watched during the erection process. And I think that what we have done here so far today is examine quite a broad range of issues. We have extensively examined what causes structures to fail. We've shown some examples in pictures of things that are bad practice. I've got some here I'd like to show you. If I can find the... Sorry. Here we go. This is what happens if you don't do it right. This was a brand new tent from an Italian manufacturer, and it was the first day up. Tell me how that happens. I'll show you how it happens. A bit washed out pictures, my apologies. We had... Damn, I even got that piece on there. I don't know if you can see that. Can you see that there? Running underneath that seam, there's a seam running down here. It's a 5-ton, 50mm wide plastic webbing. And they've punched a 40mm hole through it to put that clamp on. So the webbing's got 5mm either side. And of course it's sheared. I have got a picture of it somewhere. I'm not surprised it's not in this directory. And that failed in the middle. At this point, there, and ripped all the way down. Now, once again, luckily, the only things that fell out of the sky were the side poles. It did have people in at the time, and no one was injured. And the wind speed wasn't more than 20 metres a second at the time. That ripped because of the tension in the roof. And there's numerous examples we could make of that. And once again, on a big top, it's a topical thing because people are talking about making sure cables are tight. And you can actually induce failure in the king poles if you don't leave the main guys slack when the roof's up. You need to let the membrane just breathe a little and let it move. Not a lot, not banging about. But if you don't, and the bell ring that lifts the membrane up leans against the king pole, you can damage the king pole enough for it to fail. So it's a pin-jointed mast, you might as well just let it move. So I've seen safety officers on site insist that the contractor tighten them up, and they were actually giving false advice. Now that really should be in the tech book, in the TDS technical handbook. The other question you ask yourself, this beautiful little tent, this. The other question you ask yourself, that tent was designed for southern Italy, it wasn't designed for the UK. It was actually designed for more like 22 metres a second. Nobody stopped them using it yet. We get frame tents coming in from Spain, south of France, Italy, Germany. None of them really meet the requirements of the more extreme weather in the UK. That doesn't mean that the central UK and the Midlands and everything, but around the coasts and the edges and up in Scotland, they're using structures at events which really don't meet the standards. Let me show you some, where are we? Sorry about this, give me a second. I'm going to finish off with the directory says failure slides. I'm not going to show you these again tomorrow, so I'm getting them out of the way. And it's a reminder, and these are from South America, and from the Madonna concert, and Elton John in Mexico, and we could go all over the place, and Indiana. But this is what happens when you get it horribly wrong. That's in Denver, Colorado. That's Puckle Pop. That's Indiana. Can't remember. Puckle Pop. Puckle Pop. There's the masts laying down. This is a broken truss in... Can't remember where that was. That's a good one. Somebody's garden has gone. A lot of these are documented on the PSA website, I believe, aren't they, Tim? There's a list of events, isn't there, on the PSA website?
Yeah, list, but not the photo.
There's no photos, no. There's one here in particular, I'm waiting for it. Here we go, this one here. Now that is horrific. I'm going to come back to that in a minute. But this shows you what happens when things don't go the way that you would expect. And we're not going to flog it to death. I'm not bringing these out again tomorrow. We've got enough to get on with tomorrow, because we're winding things up today. There you go. That wasn't designed to do that. The red and white tent was. Okay, we've seen enough. That particular that one. They actually meet all the regulations doing that, and it scares me to death. I'm not sure it meets the regulations with him standing on it while they're hoiking it up into the air. But while they're lifting that whole roof up in one piece, they only need the slightest gust to come up, and there's just major damage. And there's so many crew there, look at them, they're all standing on the surrounding scaff. I really hope we don't allow things like that to happen in this country anymore. And I do all of that, I show all of these pictures as a justification, not that I feel we need it, for being here today and tomorrow. And you've all been wonderful. The responses have been better than I thought. If you have any, are there any questions and answers you've got left for today? Anybody got anything else they want to cover? Well, I'm going to wind things up for today then. I want to thank Simon James for his efforts. Very good indeed, very clear and very concise. I want to thank Alan for what he did earlier. I want to thank you all for being here and being patient all day. Tomorrow we're going to go some more nitty-gritty. We're going to do more end-user stuff, inspection, anchors, structures and erection procedures. So plus we've got Steve Corfield going to explain, a bit like Simon did, about his issues with stages. We've got Gavin Bye here from the Health and Safety, and Professor Pavic is going to give us a while on his new monitoring techniques. So we've got a full day again tomorrow. The dinner's 7 for 7:30. It's in the room next door there. You get to it through the bar. And for those of you that are staying, we hope you've enjoyed the evening, and we'll see you tomorrow morning. Thank you very much.